Why the options pattern is great for security. Hello, my name is Dima Kotik. I'm an application security engineer at Security Journey. We provide training for developers by developers for all matters related to security. The goals of our presentation are the following. We will review the options pattern for complex object initialization. We will discover the types of vulnerabilities it can prevent. We will try to improve the classic paradigm to maximize security. And finally, I hope this talk inspires you to adopt the pattern when it fits. The examples will be provided in Golang because I like it very much and they fit very nicely on slides. Well, let's get started first by defining the problem. And the problem we have this year is the OWASP Top 10 number 6. Security misconfiguration. It doesn't matter how well your application is protected by static code analysis, dynamic code analysis, firewalls, all sorts of great tools if it is insecurely misconfigured. So many services in production right now are securely misconfigured and are attacked and exploited easily. Attackers love different types of misconfiguration, notably, for example, a hamstrung cipher. You can provide a weak source of random for your crypto, a weak algorithm, a weak key length, or a set of parameters that makes the cipher unusable. It is also common to see services shipped with missing access controls, something that was supposed to be not accessible, protected by credentials, was shipped without. And of course, debug backdoors. To get our services running well, we need instrumentation, we need additional facility and observability to find out what's wrong. So many of our services are running with those additional observability helpers and backdoors in production. And when an attacker discovers a backdoor, especially if it's using a weak or default password, it is for them like candy, easy to take. The difficulty with security misconfiguration is that two common pieces of advice on the street are not super helpful. The first one is, of course, we're called to stop misconfiguring services, and yes, we can try, but with sophistication and with growing complexity of our networks and applications, it's very difficult to keep up. The second one is to use an analysis tool, a static or dynamic analysis tool that can detect a misconfiguration problem, and that's good and helpful. However, the cost of discovery of a misconfiguration problem is great. And the static analysis tool cannot detect it unless it has seen somewhere else in the wild. Do you want to risk it? The real question is, can we do something on the engineering side to make our application resistant to misconfiguration? And yes, we can. Enter the options pattern. The options pattern is a flexible object provisioning strategy using a list of independent object modifiers. Those are typically functions. Imagine your application is an engine and you will have a list of tweaks applied sequentially to your engine, each one helping with one or two parameters in isolation to get our engine, to get our application ready to run in production in a secure way. To demonstrate this, let's go back to a Java classic, the builder pattern. Suppose we need a bank account and we will call bank account builder, a class that creates a class. And each step of the builder pattern uses a list of options or a list of settings that are sequentially applied to the object, and then the final build method returns our bank account. This is very familiar. The options pattern is like an odd cousin of the builder pattern. There's a lot of superficial similarity, but there's a great difference for security, as we will see. In our second example, I'm showing you how to apply an options pattern also to initialize our bank account. And what we do is, instead of calling a string of methods, we're passing a list of options to our constructor. We're using an option with client, with email, and with newsletter preference. On the surface, it looks the same, very similar syntax. But again, in application, it's very, very different. And there is one significant difference. But an easy way to think about it is that a builder pattern is when an object constructs another object. An options pattern is when an object is constructed using a list of functions, typically closures. How do we write the option? Well, this is the classic that I first learned in the Go community. First, let's define the option type. And an option type is going to be just a function which takes the pointer to our engine, to our main thing that we're trying to configure. In this instance, it is the bank account. And we will then spell out one option, and we'll call it with email. It will take a string, email, and return an option. You can see the closure here being returned. And the closure will simply modify client email by applying the email string provided earlier. In Golang, lowercase letter parameter means a private parameter. We want to make sure that nobody can misconfigure our parameters by accessing them directly without going through the proper channel, through the proper option, so to speak. And so this way we're protecting our object from misconfiguration, not just by the wrong setting, but also by bypassing the proper mechanism of setting. So we use private parameter. How can we improve this classic? We improve it by applying 4 categories of correct security failure to our application. We want to fail early, as soon as a problem is detected, and of course object initialization is about as early as you can fail. We want to fail safely so that the failure is handled upstream and the program just doesn't crash with a stack trace. We want to fail explicitly so the cause of the failure is known right away, and of course singularly. Nobody wants to observe a cascade of failures, of 5 or 6 failures, without knowing which one is the real cause in production. The cause needs to be singular. And the truth is, if you're serious about security, insecurely configured services should not even start. It is the responsibility of your application not to start if it was given wrong settings. Weak settings are also a failure state. How can we improve the classic options pattern to account for the 4 failure states or ideal failure conditions? We will simply do this by modifying our signature of our definition there, of the option definition. It will still be a function taking a pointer to the object being configured, but it will return an error. Of course, in many languages, you may want to throw an error. In Go, we return errors. This is just a common idiom. In effect, it doesn't matter so much, but that's the best way to write it in Golang. So what kind of difference does this make? So we're having the same option with email that will take email as a string and return the closure, but this time we will validate the email inside the option and return an error if there was one detected, or throw an error if you're writing in something other than Go. It is a subtle difference, but it makes a great difference. To apply those options, all we do is we have a constructor. Let's call our constructor a new bank account, which will take a list of options and return a pointer to a bank account and an error if there was one discovered. We will initialize a blank bank account, and then we will iterate through every option provided to the constructor, apply that option to our resulting object, and check if there was an error. If there was one, we want to halt the execution immediately, return nothing for our pointer, and also return wrapped error, which we will mark as initialization failure so that can be gracefully handled upstream. Later on in the constructor, we will check if mandatory parameters were set, but we will not validate our object in the constructor. All the validation code should be moved inside the option. How does this help us? What is the outcome? The option pattern helps us prevent 3 categories of problems. The first one is invalid or insecure state. If something is missing, something is null or improperly configured, is missing a port or an address, or some kind of critical setting, we want to detect that at initialization. Second, we want to detect failures originating in parameters. Sophisticated objects can take behaviors for parameters. Do you know how those parameters providing behavior were configured? Who configured them? What config was used? Are they actually working? The option pattern allows you to examine a sophisticated parameter that has behavior or passes behavior to your object to make sure that it actually is fully functioning like it's supposed to and it is properly initialized. And finally, conflicting parameters. It is very common for a security vulnerability to emerge not from one or two parameters, but from interactions between them. One parameter can undermine or make insecure another, or the combination of several can put your program into insecure state. The option pattern can help you detect those conditions and cancel the execution before everything gets out of control. Of course, I'm saying how great all of this is, but there needs to be some limits placed on when to use this. There are at least 3 usage criteria that you need to look for before you're using an options pattern. Typically, you will use it only one time per package, and the package has to be sufficiently sophisticated to warrant this additional work. 3 things to look for. First is flexible behavior. Does your initialized object change its behavior based on settings given to it? For example, are you using providers, drivers, caches, a networking layer of some sort, or a protocol? If you're taking those as parameters, an options pattern can really help you validate them. Second, if you have some parameters that are mandatory but not others, the options pattern can really help you a lot. If all your parameters are mandatory, you may be better off with something more straightforward and easy. But when you have some mandatory and are not, and they can even change which ones are mandatory depending on which parameters are provided, the options pattern is much better for that. And finally, if you have entangled parameters. Those are a class of conflicting parameters that affect each other. The options pattern can help you resolve gracefully at initialization any kind of entanglement in such a way that it precludes or prevents security vulnerabilities. Let's look at an example. Suppose you have a hypothetical asset encoder that will take a stream of bytes and encode it, and we will use it in our IoT device, so it will be pretty straightforward and simple, and it will stream the encoded information out of the IoT device. And let's say we're writing an option, and we'll call our option with block size and memory limit. And we're putting size and limit as parameters of the same option. Why are we doing this? Because those two are related to each other. There are at least 3 conditions of entanglement that affect both of those. First of all, the limit has to be greater than 0 and greater than size. Second, the limit has to be a multiple of the size because we don't want to end up with a buffer that's overfilled or underfilled eventually when we get to the last block. And finally, you may know you have some protocol-based requirements or limitations. For example, in this instance, there's only 2 bytes for block sequence, so you know there's going to be a limit imposed on that just from the protocol. In Golang, all those 3 things are fairly benign, but they may lead to vulnerability. But if you're using low-level language, like C, for example, or even Rust, any one of those 3, right, in certain conditions can cause you trouble. They can create a state for DOS, remote code execution, buffer overflow, anything you can imagine. And of course, you want to check those to preclude that possibility inside the option. And after you validate them together, then you assign both of them to your object. This helps you prevent entanglement because if somebody else goes and modifies the size independently, they will not be able to do that outside of this very helpful protective option. Also, please note that this creates what we call self-documenting code. When a person is using your object and they're using an IDE will give them hints on how to initialize it properly. And with a list of options, the consumer of your API will see that size and limit are together in the same option. It hints to them that they have a significant relationship between each other. And it makes your initialization procedure even more secure because the person using it knows something is up. This is self-documenting code. We can keep going. There's another improvement to be made here, and it's called option grouping. Option grouping can allow you to use isolation, clarity, and safety by combining options together. How does this work? Well, let's write a little helping function we'll call it our little helper with options, that will take a list of options and sequentially apply them to the pointer of our main object and return an error if there is one. We have already written something like this in the constructor, so why are we pulling this out into a separate routine? Good question. We'll look at it in a second. But first of all, note that we will change our constructor and replace that whole loop that was iterating through options with our little helper, and again, wrap the resulting error as initialization failure. What does this helper allow us to do? We can set up option sets. We will unleash our little helper by designing default options. How convenient is it to have your object configured securely by default, but also make it easy for the consumer of the API to click on just one routine and without having to parse through many setters and getters and factory functions, know exactly how it's supposed to be used with a list of all the modifications that are secure by default, and also know which ones they may want to change. This makes it for a very lean and easy to use API. Another way to set up a set of options is to use an option set called with debug option. With debug options, we'll take a list of options and present them together as a set. Well, in that list, you could use unsafe private options. Why private? Because, for example, like a debug backdoor is not something we will ever want to see in production, or someone use carelessly or flaunt without careful consideration, and by accident include it in our object and ship it. By bundling unsafe private options together in an option set, we make it very clear and exact that those types of vulnerabilities will not end up, or those types of dangerous or weak options will not end up where they're not supposed to, because a person will have to either use that entire set or refuse that entire set. And they can see right away from object initialization which set is being used. And of course, since you're writing an option set just for debugging, why don't you just check right away that your instance is not running in production? Because if it is, you guessed it, you need to raise an exception and halt the execution. Finally, you can use option sets for visual grouping. Sometimes you don't have entangled parameters, but for clarity, you want to have on the same line 3 related things and comment on them together. You can group and nest by using our little helper as much as you want to your heart's content. In the end, it will not make a difference for initialization, but it will provide you a convenient and well-documented way to present the way you're using your object to your team. Let's put all of this together and look at a few examples which are a little bit more complicated. So suppose we're writing a hypothetical distributed secrets manager. Is that sophisticated enough? Oh, yes, it is. So we'll use a set of peers that we can pass, or even a peer discovery protocol. We can write an option for that and validate each one of the parameters being set. Of course, we'll use a caching layer because that's very good for performance. Redis is kind of a standard caching layer, and we'll have to write an adapter for our object, but we'll set it up as an option. We will also need a list of allowed ciphers if we want to do cryptography without relieving the keys. And we'll need for our secret manager rotation window and a max key lifetime. As you are drafting the options, you're realizing, okay, that those two, rotation window and max key lifetime, are pretzeled. They have a relationship between them. So let's think about this for a second. What can we do? Should we combine them into one option, like an example I showed earlier? Well, perhaps, but what if there are more options that come up later that can affect those two? Then there's another question. What if the cache layer was misconfigured? What will happen? It could lead to broken access control or ghost keys that should be long expired, but they're hanging out in the cache layer because somebody wrote the config incorrectly or provided incorrect configuration in production. But also, the cache configuration needs to account for the rotation lifetimes as well. The max key lifetime cannot be greater than 5 times the rotation window, because then it defeats the whole purpose of key rotation. Those things all have to be accounted for, and we realize all of a sudden it's not just 2 things that are pretzeled, it's at least 3 things and maybe more. What's a good way to handle this with the option pattern? Well, instead of combining the two, rotation window and max key lifetime, let's take a hybrid approach and write an option called with synchronization strategy and provide a list of keyword settings to initialize our strategy. You can see there at number 1, we'll leave a comment because we expect perhaps that maybe more parameters will join the synchronization strategy later that we don't know yet. And second, of course, since we're using a structure with keywords to initialize those settings, we're in effect combining two different initialization approaches, options pattern plus keyword initialization. We can actually use that structure and share it internally between our different option sets. And we can use those parameters to present them to our caching layer to make sure that key expiration in cache matches the key lifetime provided for the rotation. This process makes our API hard to misuse. If it's well written, it will be impossible to misuse. Notice the pattern helps you think, the options pattern. Maybe we can write a book and call it Options Pattern Design. I'm just kidding. Let's look at some more examples. Suppose we're writing a hypothetical microservice, and let's write some options for that with host and port. Those two are related to each other, they're entangled. You can see the port is an integer, not a string, because we want to lean on the type system to make this even more secure. We will need a TLS layer. Acme is a good way to go, so we'll write an option for that. And also timeouts. Microservices are very, very reliant on timeouts regarding security, right? We don't want our APIs and our calls to hang or to tie up resources by having really long tar-pitted connections. All sorts of things can go wrong. And here we will use a keyword setting in a structure by defining ingress, egress, and idle session timeouts that can be shared between both internal and external API calls to make our service stable and resilient against the DOS attack. Of course, we'll need a secrets manager because microservices need a rotating secrets manager, and we'll use a KMS adapter that we'll write later. Throttling strategy, that's a requirement. If our service does not throttle, it is very rickety and vulnerable. And let's take a strategy that will throttle by IP. You notice a behavior is being passed. Great for the options pattern. We'll have a retry strategy, another behavior, and we'll use immediate retry 2 times when a call fails or a connection fails. Of course, we'll need a state backend. Redis is great with an adapter, and of course, a logger. It's a good question, where is a good point to put loggers? Sometimes you want to be tempted to put them everywhere, but they create side effects and they make things that are not so testable. It's an additional complication. But when you're using a sophisticated object that requires options pattern, typically you should have an option called with logger. And what you really want to do is write an interface so you can satisfy it with a logger of your choice or perhaps multiple loggers. That's a good way to go. Observability adds to security, and here is an option to do that. Let's look at another example. How about we write AWS Fargate containerized task launcher? So a task launcher, we will define tasks. Fargate is basically a layer over Kubernetes cluster. All sorts of fun comes with Kubernetes clusters and security, right? They're difficult to secure. So Fargate is already easier because it's an API written on top of it, so you don't have to worry nearly about as much for security. But still, there are things to check. The first thing, of course, is AWS configuration object, right? So we need to have a proper config that has all the right roles configured and access to the right access control points and the right APIs to launch our tasks. So we'll make an option for that, and we'll validate configuration inside the option. Of course, the cluster name, because we don't want to just be launching containers all over the place. We want to restrict them to a certain cluster, so there's some control, singular point of control when we can turn off the whole cluster and shut the service if something goes wrong. We'll need a URL factory, right? Because eventually those containers will need to be accessed somehow, and the public IP will need to be converted to a link. Maybe we'll be passing a token of some sort as well for access management, and a URL factory method. A behavior is very a convenient way to do that. We're passing behavior using an options pattern. Next, Fargate takes subnet configuration and security group configuration. A security group in AWS is basically a firewall set of rules. And the way Fargate is set up is that it takes both subnets and security groups without differentiating between them. It doesn't care if they're private or public, but we care, right? Because we need to make sure our containers are either public or private. We never want to have one that's supposed to be intranet private launched with a public subnet configuration. To preclude that, we can actually write an option that will differentiate and protect the Fargate API by checking our settings, so that when we provide the subnet ID, let's go ahead and just peek at that IP address of that subnet and see maybe if it starts from 10.0, right? Because that will indicate a private IP, most likely. That's just a simple check, but you can be more sophisticated than that. But the point being is that when a person configures your object, this will prevent them from publicly exposing the container when they did not intend to. Otherwise, you're just relying on that ID to be pointing to the correct subnet. A person chasing a deadline, will they present you the correct one? Yes, you guessed it. Very likely not. So have your option, check for it. Similarly, a security group ID option can access that security group and check the ingress and egress firewall rules to make sure that only certain types of traffic gets in and out of your container. And for each one of those options, you can also wrap them with additional functionality when you are presenting them to your Fargate containerized task launcher. This is called security built in, and even if the API itself did not account for those failure states, you're accounting for it in your implementation. Fargate API does not differentiate public and private networking dependencies, but we must. And the option pattern here will help us do that. Let's look at a hypothetical encrypted network tunnel. Those are fun to write. And we'll need to have it very flexible and configurable. And let's set it up with a certain packet size. Large packet size means greater efficiency for processing, but also greater latency. And who knows where this encrypted tunnel will be used. Will it be an IoT device? A backup server? Who knows? We want that to be configurable. And so we're going to make an option for that. Second, of course, if it's encrypted, it will need a key provider, and we'll need to write some adapters for different key providers that we're using. So there is a security built in, not just in initializing the key provider, but also validating that it's working correctly. We will also need a recovery fallback, right? What if our instance that's providing the network tunnel is rebooted? Our protocol could be stateless, like WireGuard, or maybe it's stateful. If it is stateful, we'll need a recovery strategy, and we could write a journal rollback strategy so that even if there is a reboot or some kind of a problem that shuts down the network tunnel, it can rebuild itself when it wakes up. A nonce factory is so important because nonces will have to be synchronized centrally if we're using multiple instances or if we're managing connections at scale. And there, of course, we can decide if we can use like a local nonce cache or a networked one, or even use something really fancy like etcd with Raft, a protocol for synchronization. Of course, we want to handle errors gratefully, and with error handler is a way to pass a closure to respond to an error. That's so convenient to have on just about any object. Sometimes you want to respond to a particular error state, but maybe you're just hunting for one type of error, or you're interested in a particular type of error. Pass an error handler. And by the way, nothing stops you from repeating the option multiple times. If you would like multiple error handlers, you can write it in such a way that they're appended to a list that will be iterated when an error does occur. And this will give you instrumentation for logging, for recovery, for alerts. And alerts are good for security. Well, there is an elephant in the room here that I did not even mention this whole time. Think back. What are we actually doing? we are pulling out complex validation code out of the constructor and isolating it by concern and behavior inside singular functions. The options pattern is the most testable initialization strategy you're ever going to get. Because you're isolating one or two parameters per function, you're already setting up code that's testable without having to go through multiple factories or multiple builders and validate each one. You are isolating concerns and make them easy to discover for bugs and to check for security by writing a battery of unit tests on each. This is a wonderful benefit of the options pattern, and of course we know that testability and security are closely related. The earlier you can test, the more thoroughly you can test, the more you can isolate, the better your security will be. And this will give you the advantage of writing your tests in such a way that you can handle high complexity with great security. OWASP top 10 number 6, security misconfiguration. Number 6, can we remove this vulnerability type from OWASP top 10? I believe we can. Use the options pattern. It is not the responsibility of the consumer to keep your app secure. It is your responsibility as a programmer to write your app secure. An insecure configuration is a failure state that needs to be detected and needs to be rejected early in the program execution, and then this will go away. Some key takeaways. If something can be misused, it will be misused. Be secure by default, and that means weakened services should not even start. In the cloud, in a sophisticated system, it's just a matter of time before somebody presents a wrong configuration or old configuration and the service falls over. Build the security into the program. Use the options pattern to detect the problem and fix it or prevent the program from running if there is one. Second, the options pattern guards against misconfiguration, invalid initialization states, and other vulnerabilities. Third, the options pattern is convenient for automated testing. I would contend it is the most convenient initialization strategy for automated testing. Testable code is reliable and secure. Use the options pattern. And fourth, I hope I'm able to inspire you to implement the options pattern in your next major version release to bolster security with a boost of code readability, reliability, and resilience. Your program, your API, your library will be easier to use, it will be fun to use, and secure to use if it has the options pattern at its top API interface. If you're interested in this subject, here are a few more resources to consider. First of all, there's a classic presentation by Dave Cheney on the options pattern, which is very excellent. There's an article, if you're more into reading, explained by Mark Sagi-Kazar. There's also a really good blog on how to apply the options pattern to database queries. It's a very interesting use case of a similar approach. And finally, there is a full example source code gist with comments of the options pattern as I presented it in this talk that you can access by that QR code. It's compilable, it will run, and it gives you an opportunity to study this in more detail. Thank you so much.
Dima, thank you for the great talk. It was inspiring. I'm a big fan of this idea, making software development much less convenient for introducing vulnerabilities. And yeah, it was very much along these lines. So at one point you just said that you jokingly have an idea of writing a book on that. Why is it joke? Why is it a joke though? I think it's actually a good idea.
Well, it was more of a pun to the trend to make fads.
Oh, I see. I see.
Like
Didn't catch that. Sorry.
yeah, well, because people will take an idea that may be a good one, like test-driven design, and then it's all like really crazy until people get really tired of it. Because most of those ideas, they need to be weighted and carefully applied. Like I am a big fan of test-driven design, but in practice, I maybe use the approach perhaps 20% of the time, and that's not a constraint of choice. It's just what the budget and how much time I'm allowed to work on a solution. So, and my time is very valuable. So what I'm going to do, I will use the most of the approach's benefit, but I'm not going to just ride it like a fad and put it everywhere. So options pattern is kind of like that too. It has uses, it's great, but don't put it everywhere.
Yeah. Yeah. The paradigms should be used to the extent they are useful for. If they're not, that's just the religion, I guess, already, not using the paradigm. Okay. Do we have any questions from the stream or in Zoom? I remind to all our attendees that if you want to do it out loud, you just raise your hand and I will allow you to talk. And if you don't, you just type it in. I think people are just hungry.
Right before.
I sense low sugar levels in this chat room. Okay, then, Dima, that I don't know. Certainly, you have to have certain background to grasp all the concepts that you just outlined. And yeah, for me, it was a good introductory talking to the topic, and I most probably will delve deeper into it. But I am not sure I am capable to pose any questions. And I think that's the theme out there in our audience. But nevertheless, that was very exciting.
Security professionals, say about shifting security left. That's like a really big buzzword too. But when in practice you say, how do you do this? Well, that's one of the easiest way. That's one of the best way to actually shift.
For sure. But when security professionals talk about shifting left, normally then they mean implementing some SAST or other DevSecOps stuff, and this is like, this is it. This is culture. Yeah. So it's like thinking differently, and by applying thinking patterns, just avoiding risky areas, right? It's like switching from, no, it's a very rough example, I understand, but it's like switching from C++ to Java, okay? There are many things you cannot do in Java that you otherwise would be able to do in C++ and get hacked, right? So yeah, shifting the paradigm is one of the ways to shift left and to start applying security practices early in the SDLC. But unfortunately, the market buzzwords are dictating other strategies, like implementing some code analysis or
usually
some
product
other stuff.
Yeah.
Usually it's a solution, unfortunately. Throw money at a problem until it goes away. Yeah, leftist left of all lefts in shifting left is threat modeling. Virtually no one does it. Okay, just set some time aside, put it into threat modeling. It's a crazy idea for everyone because we would otherwise use this time to implement features. Sad story, but unfortunately it's true.
But if you put it correctly, it's 1/20th of the cost of fixing than preventing, right?
I'm a big fan of this idea, but I have background in actually trying to sell that mindset. It's very hard. Even when you're talking to a very analytical person who actually understand the math and they know the idea about the mathematic models behind these concepts. They may get it, but they cannot push it through the bureaucracy and the decision making in the business, in the actual business, just because security is uncertain. You know, business people do not have good intuition about prevented losses. They're thinking about top lines, bottom lines, but prevented losses is something very virtual. It might happen, might never happen. Why bother before it happens? And that's it. But yeah, if we one day have enough data in order to make something out of it and state as a fact, maybe that will help. But until then, yeah, this undercover magic of doing stuff that is similar to what you just described, maybe the only way we can achieve more secure software. Just not letting the business people know that we do it, and yeah, moving in the right direction this way. I think it was a very sad note to end to wrap up such an optimistic talk, but nevertheless, that's how it is. So thank you very much for bringing this up. It was really interesting for me personally, and I hope that everyone enjoyed it as well. If you missed it, if you just joined, rewind and watch it, or just watch it when it's published on YouTube in a couple of weeks. Dima, thank you very much. It's nice having you here.
Thank you. Bye-bye.